Hello all. I hope everybody is able to hear me out. Can you give a quick yes? Yeah. Can you hear me out quickly? Okay. Very much clear. So we'll wait for some time till everybody joins and then we will probably start. So till then, I would suggest everybody download this GitHub. Just let me share you the GitHub quickly. Okay. Just give me a second so that I can share you the GitHub so that we can discuss about today's class. So I will be coding along with you. Okay, so that you can actually follow me anyhow. So here we go. Everybody, I have given you the collab link, or should I put it in the description also? Okay, so I hope everybody has got it. Yeah, so please download it quickly, everyone. Yeah, please download it. Okay, just reload the page. In the description you'll be able to find out the collab link. So quickly go ahead and download it and just give me a confirmation once you get it. Okay, till then I'll just wait, but I hope everybody is doing fine. Everybody is doing well, right? Yes. Okay, now let me share my screen in front of you. What all things we are going to do? We are going to discuss a lot of things quickly. Just give me a confirmation if you're able to see my screen, right? So today is the ninth day. Oh, it's amazing, right? Ninth day of NLP session. That is natural language processing. Today we are going to cover up two main things. One is word embedding layer, practical implementation we'll see. We have already done, word to vec, right? We have used word to vec. But word embedding layer, there is something in a neural network which we are going to see how to do this with TensorFlow and Python So we'll discuss about this, both the things. Okay. Second, we'll do an end-to-end project with the help of Lstm. Let's take a sentiment analysis project so that you get an idea of how to train it. Okay. And um, we are basically going to discuss both of these things. Okay. And we'll discuss in an amazing way where we'll be discussing both the now till the last class, right? I mainly focused on one very important thing, is that how to convert word into vectors. So I hope everybody has got an idea about word to vec. So anybody who wants to say how does a word to vec converts a word into vector? I think we have done this. Today we'll focus on the in LSTM also, or in neural network we have something called as word embedding layer, and this will also convert your words into vectors itself. Okay, this acts pretty much like word to vec, but the thing is that how do we train this? Today I will be showing you. Okay, the training part. We'll try to train this entire data set by just seeing some examples. Okay, everybody clear what we are going to do today? Okay, yes, can I get a quick confirmation if you are clear too much, or not interested in class today? Hmm? Guys, some response should be there. If not, hit like. Hit like, at least make it 100. And now people will lose interest. So probably I'll make this session, as today is the last session on NLP. Or let us do after a week time, if you're getting bored in things. Okay. So if you want to do like that, I'm ready to do that. Okay. Let's take a gap of 1 week so that we'll try to do it in the next week. Okay, if you want. Okay, perfect. So quickly, let me just share my screen to you. Now, what we are going to do is that, see, word embedding layer I'm going to show you. Okay. And I'm going to show you like what all things we are going to do in the word embedding layer. First of all, in the word embedding layer, we will be considering some sentences. Let's say, so sentences which will be specifically having words. Then for the first step, what we are going to do after we get the sentences, we convert this into one hot encoding. I hope everybody remembers what is one hot encoding, right? So we are basically going to use one hot encoding, okay? And okay, so one hot encoding basically means what? I hope everybody remembers. Before considering one hot encoding, what we have to do, we have to basically take up a vocabulary size. Okay, vocabulary size. After considering one hot encoding, then the next step, what we do a step which is called as padding. Okay, I will explain you each and everything how this will happen. Okay, now in padding, why we specifically do padding? There are two types of padding, which is called as post padding and pre padding. And pre padding today is super important. Okay, if you know this steps, probably you'll be able to work with any kind of NLP data. Okay, post padding and pre padding. Then the fourth step, what we will do is that we will convert whatever one hot encoded values we have, right? This one hot encoded values will get converted into vectors. Okay. So let's start one by one. Okay. Now, first of all, tell me if I have a sentence like this: Krish likes pizza. Okay. Okay. And let's say Shyam likes burgers. Suppose if this is my sentence, let's say this is the example of my sentence. Okay, let's say I have two sentences and I want to basically see how this will get converted into this one. Now, let's say if my vocabulary size is somewhere around 10,000, or let's say my vocabulary, what does vocabulary size basically means? Number of unique words. Let's say if it is 500, let's say the total number of words that I have in my dictionary is 500. Now, if I really want to perform this one hot encoding for each and every word, let's say, then how it will become? Krish will become something like this. Let's say Krish at one hot encoding will have all the numbers as 0. At an one point, let's say this is the index. Let's say 325. And this index is basically saying about Krish in the vocabulary. So this side, it will become 1. I hope everybody remembers with respect to one hot encoding. Yes. I hope this is pretty much clear. We have discussed already. And remaining all will again be zeros. Right. So this is what one hot encoding is all about. Right. And similarly, if I go with the next word, let's say likes will be given in another one hot encoding. And let's say 000 will be there. There will be one index, JKL. After K only it will come. Let's say in the index, let's say 328, like word is there and remaining or will be 0, right? So in this specific way, why 328 index I have taken? Because L will come after K, right? JKL, right? So it may be nearby. Now, considering this one hot encoding, I have to take this entire words and then probably create an embedding layer and convert this into vectors. This is what we want to do. And this will be basically done by a embedding layer in deep learning. Okay, so there is a deep learning embedding layer, like how we have dense layer. We can basically train this network completely. Okay, so this is what we are going to do and I am going to show you. And once we complete this, because this is the first task, this task actually helps us to do text pre-processing. Okay. In machine learning, you can definitely use word to vec. Here also you can use word to vec, but it is always good that whenever you have your own data set, this is not for pre-trained. We are not going to use any pre-trained model. Instead, we are going to use some data set. Then we are going to train it using embedding layer, and then we are going to find out the relationship. Now, quickly, the file that I have actually given you, I'll go and show it to you. So I hope everybody remembers this. I hope everybody has got this file. This file is in the chat, pinned comment, or even in the description of this particular video. Just reload the page. You'll be able to find out the link. Has everybody got this file? Yes. Yes, everyone. Have you got this file? Just give me a quick confirmation so that I can start. Yeah. You can find out the file in the pinned comment or in the description of this particular video. Okay. Just reload the page. You'll be able to see it. Okay. Okay, let's start. Now the first step, I'll just go and change my runtime. I'll make it to GPU. I'll save it. Okay. So this is the Google Colab. You can basically see from it itself. The first thing I'll do, I will install TensorFlow GPU. Okay. Because I'm going to specifically use TensorFlow GPU. So quickly execute it. It will take some time to get executed. Let's see how much time. It is somewhere around 511.7 MB, right? And I'll show you how, with the help of TensorFlow, you will be able to do one-hot encoding and all. We will try to have a look. Okay. So this will probably take some time. Let's see how much it will take. So once this is installed, because we are anyhow going to use TensorFlow, right? So here now you can see TensorFlow installation is basically happening. Installation is done. Okay. So the installation is taken place. You can also execute along with me. Successfully installed. Okay, fine. Now let's go and import TensorFlow and see the version. Okay. Import TensorFlow as TF. Now I'm going to print TF dot underscore underscore version underscore underscore. So this is got executed. Okay. So now the recent version is 2.9.1. That is what I'm actually going to use. Okay. Now how to do, first of all, one hot encoding we are going to see. Okay. So there is a library from tensorflow.keras.preprocessing.text. I have a library which is called as one hot. Okay. Now this one hot will actually help you to do one hot encoding. So quickly let's import this and let's try to see. Okay. So I'm just going to execute this. Okay. So I have got executed this one. Now let's consider I have some sentences. The sentences you can see over here. And our main focus is to convert these sentences into some kind of vectors. Okay. So I have the glass of milk. I have the glass of juice. I have the cup of tea. I'm a good boy. I'm a good developer. Understand the meaning of words. Your videos are good. Okay. So these are my sentences, and I'm going to show you how we can basically use one hot encoding on top of it, and then later on convert this into vectors using embedding layer. Okay. That is what we are going to do. Now, if I execute this, you will be able to see these are my sentences, right? So these are my sentences here. You can clearly see. Now, the next thing that I'm actually going to do, in order to convert the sentences into vectors, the one important thing is that you have to initialize the vocabulary size, right? I showed you over here. You have to specifically say what is the vocabulary size. Okay, vocabulary size. So here I'm going to take the vocabulary size of 10,000. Let's say in my dictionary, I have to take this words and probably train it with the vocabulary of 10,000. Okay, so let's execute this. So this will basically be my vocabulary size. Now, in order to convert this words into one hot representation using this vocabulary size, see, just going to use this one hot, and this is going to convert this into vocabulary size. I mean, the indexes, it is just going to go and capture those indexes which has ones, okay? Because over here, you can see over here, one is over here, right? When one is over here, the information that comes out of it is basically the index in that specific vectors. Okay, wherever there is one, that is basically vectors. Yes, Chetan, you can definitely use word to vec. Again, I'm saying you why I'm specifically using this, because here we have our own data and we really want to create our own embedding layer and word to vec kind of vector representation by ourselves. Okay. So what I'm actually going to do now, I will iterate through each and every sentences. See over here, for each and every sentences, I'll say for words in sentences, and then I'm going to use one hot, and I'm going to give the words in the parameter and vocabulary size. Okay. When I give this two parameters, see, one thing will happen is that I will get a one hot representation. That basically means for each and every sentence, for each and every word, I will be having the index number where it is 1 in one hot representation. Where it is 1, I'm going to get that specific index number. So if I execute this quickly, here you will be able to see, this is my first sentence. Now see, what was my first sentence over here? The glass of milk. Now with respect to this glass of milk, you can see the is basically in the position, index position of 2423, it is 1. That basically means out of the 10,000 vocabulary word, 2423 index has the word the. Is everybody clear? Yes? Is everybody clear about this? Yes or no, guys? Just tell me why I am getting 2423 over here, because at that specific index, the value of the, right, was 1. Very much clear? Yes or no? Each word will be 10,000 dimension. Yes, it is 10,000 dimensional. But here you are getting that every word, right, wherever the index is 1 in that 10,000 dimension, only that index you are getting over here. I hope everybody is able to see it, right? Why 10,000 vocabulary? I have just initialized 10,000. You can take it 20,000. You can also take it 500. Okay. Is everybody clear with this? Now, similarly, the other word glass. Glass is at the index 5188. It is 1, right? Similarly, over here, the off is there, and off basically has at an index of 1091, it has the value 1, and similarly 5336. Okay. Now see the difference between these first two sentences. The glass of milk and the glass of juice, right? The glass of milk and glass of juice. Tarun says it changes every time we run. Yes, because over here the random variable is not put up. This one hot, right? It has a random variable inside. It will not be fixed every time. Okay, because the 10,000 dimension, it can be different, right? Now the glass of milk and glass of juice, this both are same, almost same sentences, only milk and juice are changing. So you can see over here, both the sentences will be having the same vectors. Only the last index is basically changing, because milk has 1 at a different index, whereas juice is basically milk and juice are basically having 1 at different index. Is everybody clear? Yes. Yes. Yes, everyone. And again, I'm telling you, vocabulary size can be anything. If I take 500, remember your values of the indexes will be between 0 to 500. Okay. So if I execute with respect to 500 also, you will be able to see all the values you'll be getting between 0 to 500. Okay. 0 to 500. So you can see all these values 0 to 500. Okay. 0 to 5. If I take it 100, it will be between 0 to 100. Okay. But the larger vocabulary size basically means larger good amount of feature representation you'll be able to get it. Now, once we create this one hot representation, now do you feel over here each and every sentences have a different length? Over here you can see most of the sentences have a different length. Increases in vocabulary size causes overfitting. Not overfitting, but processing time it will take more. Okay. Yes. Okay, everybody clear now? Now everybody focus over here. Do you feel each and every sentences have the same length? How does it select the vocabulary? Vocabulary is completely a hyperparameter, guys. You can select by your own. Okay, you really need to try out with different vocabulary size. Do you see all the sentences are of equal size, everyone? Just tell me. Do you see all the sentences are of equal size or not? Is it of equal size or is it of a different size? See over here. Why I'm asking you, it is a very important question. Okay. Here you can see that here I have 4 words, here I have 4 words, here I have 4 words, but here I have 5 words, here I have 5 words, here I have 5 words, and here I have 4 words, right? So the sentences, there is always difference, right? Tell me, in neural network, if I need to train all these things, I have to make sure that all my sentences size should be fixed. Yes or no? Yes or no? All my sentences size should be fixed or not? Yes? Yes or no? Yeah? I hope everybody is able to understand. If I really want to train this with our neural network, don't you feel that all the sentences size should be same? That is the reason why I had written over here something called as post and pre-padding. Okay, this is the next step. See, we did one hot encoding. Now we are into the next step, which is called as post padding and pre-padding. Now, what is post padding and pre-padding? But before that, let me install some of the libraries like embedding pad sequences. This is basically used for pre-padding or post padding. What is pre-padding and post padding? I'll just say you in some time. And then sequential is basically for the sequential neural network. I'm going to import this. I'm going to import this. Now see, what is the maximum sentence length that you can see over here is 5. Okay. In order to make all the sentences have the equal size and length, what I am actually going to do, let me assume that the sentence length will be 8, the maximum sentence, because out of this we can definitely find out which is the maximum sentence. Over here it is somewhere around 5 words maximum. So in the worst scenario, what I have done is that the maximum sentence length can be 8. Okay. Now here, what this pad sequence will do is that it will make sure that for all these words, all these vectors right now, wherever it is 4 or 5, it is going to make it 8. Okay. It is going to basically make the size to 8. Now, how can we make all these sizes to 8? It is very simple. Either you add zeros at the last or zeros at the first. Okay. Now, in this particular case, I'm using one hot representation, which is these values, and I'm saying add padding is equal to pre. So this basically means pre-padding. That basically means to make the sentence equal, just add zeros in the initial and make it completely 8. Okay. Suppose if you have 4 indexes, then how many zeros will get added forward? How many zeros will get added forward, guys? Tell me. How many zeros will get added forward? How many zeros will get added if my maximum length is 8? How many zeros will get added forward? Tell me. This is a question for you. 4, right? 4 zeros will get added in this. What about this, where there are 5 indexes? How many zeros will get added over here? How many zeros will get added over here? Here, how many zeros? Here, where I have specifically 5 indexes. 5, if there are 5 indexes, then definitely how many will get added? 3 will get added, right? So similarly, this will happen in this way. So that is what we are going to do over here, right? Pre max let sentence is equal to length, right? So if we print embedded docs, here you can see that I'm getting 4 zeros over here, I'm getting 4 zeros over here, I'm getting 4 zeros, 3 zeros, 3 zeros, 3 zeros, zeros. So this way, the one problem that we are facing, our input size is not fixed. We have made sure that our input size is fixed. Everybody clear? Yes. Yes or no? Yes. Yes. Zeros are added in the first. If you use pre, if you use post, then zeros will added at the last. Okay. If you use pre, it will be added in the front. If you use post, it will get added in the last. Okay. So I hope everybody is able to understand till here. Okay. Okay. So right now this is called as pre-padding. I'm going to just write a comment which is called as pre-pad. Okay. Everybody clear till here? This, now any problem that you solve in NLP later on, we always need to follow these steps. Everybody clear? We need to follow these steps. Without these steps, you'll not be able to go ahead. Okay. So till now, if you're liking the video, please make sure that you hit like. Let's complete 100 likes. I know these all are free content. Nobody value free content. Okay. So let's go ahead. Okay. Now coming to the next one. Okay. What we are going to do after that. Now, if we have done till here, okay, now we will try to convert each and every value with some vectors, right? How do we convert each and every value with some vectors? Okay, how can we convert each and every value through with some vectors? So now, as I said, right, now we are having like this, right? Let's say one of the sentence basically has 0, 0, 0, and it has some index like 150, 160, 200, like that, let's say. Okay. Now what we are going to do, for each and every value, we may provide that in the form of feature representations, right? That is what to vec used to do, right? Each and every. And here, let's say my feature representation size, I'm just going to consider it as 10 because this is very small, right? I just want to show each and every feature with the 10 different features representation. That is what we learned in what to vec, right? That is what we learned in what to vec, right? So every one will be shown in the form of 10 feature representation. Okay. Yes. Yes, everyone. Clear till here? So let's go ahead and let's try to do it. So here I'm going to take my feature representation dimensions will be 10. Okay. 10. Now I will create a sequential model. Everybody focus over here now. Very super important till here. Okay. Now we are going to do something amazing. Okay. Now we are going to do something amazing. Now over here, first of all, we are going to use model equal to sequential. Okay. Then in the next layer, do you see something called as embedding layer? This embedding layer is going to work similar like kind of word to vec only. Okay. And it is going to train all this neural network. Okay. Now in this embedding layer, first of all, first parameter that you need to provide is something called as the vocabulary size. Now what is the vocabulary size? You know that. What it is? Vocabulary size over here. You have already taken the vocabulary size as 500. Okay. Now with respect to vocabulary size, the next parameter that you have to give is that how many features you want for each vector. How it should be shown in the feature representation. How much did I initialize? 10, right? That basically means each and every index out there should be represented with the features of 10 different values. Okay. That is the reason we have taken 10. Then we need to specify the input length, which is equal to the sentence length. Okay. So here the sentence length is somewhere around 8, right? So we are going to supply this. That is the total length. 3 important information. One is vocabulary size, how many dimension you want, what is the input length, and this is your sentence length. Okay. Everybody clear? Yes, till here? Everybody clear? Yo, everybody clear or not? Till here? Yes? Yes, guys, till here everybody is clear or not? Good enough? Good enough? How do we decide dimension size? See guys, since this is a very small sentence, right? So that is the reason this is nothing but feature representation. How many vectors I need to show? Right now, since I had a very small, so I'm using 10. If you have a huge data set, around 300 feature dimension is more than 5. So 10 feature dimension I have taken. That basically each and every index will be shown in that specific way. Okay. So now let's go ahead and what is the next sentence? I'm compiling it with Adam optimizer and mean squared error. I'm taking the loss function. Okay. So once I execute, and this is my model summary. So my model summary is nothing but it is basically an embedding layer, and the embedding layer is taking the 8 as a sentence length, 10 as the dimension, and vocabulary size as 50. Okay, sorry, 500. Okay, so when we go ahead and do this, and now if you take up any sentence of this, right, like embedded docs of 0, let's say I'm going to write like this. See, I'm going to show you now. If I write model dot predict of embedding docs of 0. What is embedding docs of 0? If you remember, embedding docs of 0 is basically my first sentence, right? So this is my first sentence. So embedding docs of 0 is nothing but it is 0, 0, 0. And what is this sentence? If you go and see in the first one, it is nothing but it is saying glass of milk, right? So this is the glass of milk, right? So this sentence that it is representing in the index format is this basically the glass of milk, right? Now for this sentence, if I want to see what is my feature representation, okay, all I have to do is that use this model and write predict of embedded docs of 0. If you do this, see over here, already everything is coming. Now see everything. 0 is represented by this 10 dimensions. Why 10 dimensions? Because I have initialized 10 dimensions, right, over here. 10 feature dimensions. So 0 is represented over here by this. The next 0 is represented by this. Both of them will be same. Both this will be same, right? Because it is 0, 0. Then again, if you have 0, again it is going to show over here as 10 dimensions, right? Okay. And then again you see one more 0 is there. Again it will be same with different 10 dimensions. Now comes 180. 180 word is what? 180 word basically means the. So where the is there, you will be able to see this is basically represented by the. Okay. Yes. Guys, it may not match with your data because the initial random seed is not checked on. Okay. So you may be getting different values. Okay. Then again, when we come to the next word, that is glass. Glass is represented by this 10 vectors. Right. And then you have off. Off is represented by this 10 vectors. And milk is basically presented by this 10 vectors. Everybody clear? Yes? Yes? Yes or no? Now, similarly, if I want to do for all the sentences, just write model.predict on embedded docs. Automatically, you will be getting all the values. Whatever values you have for all the sentences. Right? Clear or not? Clear or not? Yes? Is it good or bad? Right? I hope everybody is able to understand this in a very simpler way. I'm showing you the practical implementation. I'm going, hi sir, I got a job as NLP engineer. Without iNeuron, it is impossible. I got a good hike without a videos and Sanjeevan class. It is not possible. Thanks a lot. Amazing. Congratulations, buddy. Being data scientist. The name is only being data scientist. This is nice. Congratulations. You rock and you will rock. Okay. So guys, you can congratulate being data scientist because he has done an amazing work out there. Okay. How do we define sentence length? What do you consider the maximum sentence length can be? Okay. Consider that and write it over there, right? So that out of vocabulary issue will not come, right? So we definitely have to take a little bigger sentence and probably use it. Okay. Now, do you want to do some new use case? And now we have actually converted this into vectors, right? Now, what is the next step? How do we create an LSTM? That we are going to. Okay, Arvind. His name is Arvind. Okay. Okay, Arvind is there. Okay. Now, quickly, I'll give you an assignment. Do that assignment in front of me. Okay. Let's say this is your assignment. Okay. This is your assignment. Let's say you have a sentence which is like this: the world is a better place Marvels. Marvel series is my favorite movies. Movie, right? Let's say these are my sentences. I like DC movies. Okay. And probably I can also use some words. The cat is eating the food. Tom and Jerry is my favorite movie, right? So finish your blockchain series, enter into live session. Amazing. Yeah, guys, quickly, one quick announcement. iNeuron is coming up with the blockchain. Uh, iNeuron is basically coming up with the blockchain course. If you want to join, please join. Again, it is an affordable course, guys. We give affordable courses. That is fine, you know. You may be saying, Krish, promotion. No, I'm not doing promotion. I'm just trying to help you out. Okay. Instead of giving 2 lakhs, 3 lakhs, take up this course. Okay. So blockchain development, 4,000 rupees starting from 23rd July. We are going to learn so many things over here. So if anybody is interested, please go ahead. I'll put down the information in the description of this particular video. And if you want any discount, use Krish10 coupon code. So this is okay. Fine. This is fine, right? If we really want to give something good, hmm? If we really want to give something good, we can give it, right? We can give it. Okay, so don't feel that okay, Krish is doing promotion. Krish is not doing promotion. Krish wants to provide you the right thing. Okay, so that is the reason why I'm saying you. Okay, so quickly use Krish 10 if you want additional 10% off. And yeah, don't miss this opportunity. I and Navin Sir will be teaching. Along with that, we also have an Sanjeevan who is an expert in this. Okay, so please, yes, if you are interested, go ahead with this. Otherwise, it's okay. Free content is always there. Okay. Free content is always there, right? Okay. Now, yeah. Yeah, it seems late 23rd July. No, we give pre-recorded videos also, so you don't have to worry. Okay. Okay, the Tom like Jerry's. Okay. Python is my favorite programming language. Okay. So quickly do it for this, guys. Everyone, do this and try to find out the vectors if you can. Okay. And one more assignment that I really want to give up is that go to Kaggle and find out this IMDb 50K movies review dataset. Try to convert this all into vectors. Okay. And probably we may take up this particular use case over here. Okay. Okay, so here you can probably see all those are there. I hope everybody gets this link. So just to take out this courseathon announcement will be done today or tomorrow mostly. I think we have time, right, to announce it. Okay, so just take up this all questions and try to do it. Okay, try to convert this into vectors, and once you're able to do it, the next class that is going to happen will be on Monday. Monday, no, Tuesday. We'll do it on Tuesday because Saturday, Sunday I have classes and I'll be really tired. Okay, so let's do it on Tuesday. And Tuesday we'll do one LSTM project end to end, and we'll try to do something related to that. Hey Krish, please take some classes on Cloud Tech, Azure, AWS related with ML. Yes, I'm going to basically soon start ML with AWS. I'm also planning to start Dockers and all. So if you don't know, see, I've already started writing code. Okay, let's see. See, this is the code. I've already started doing Dockerization and all. See over here, you can see Dockers and all, right? So all these things will be coming up soon. So I'm probably in the next live session after this gets over is end-to-end machine learning project. How you can create CI/CD pipeline, what is this YAML file, how to do packaging, everything will probably be shown to you. So, okay. So I'm just going to do all these things, and the next one will be this only related to this will be coming up. Okay. Uh, this will be the next one. So we will try to write code from scratch. Okay. What is this setup.py and all? Everything we'll try to discuss. What is requirement.txt? What is Docker file? What is Docker ignore? How to create a package. See, housing has also become a package. How do you deploy this in PyPy? All those things I will be taking it. How do you deploy with Dockers? See, I have deployed with Dockers also. I'll show you. So this is my GitHub. Okay. I was working on this project from morning because I need to really teach you all these things because it's super important in any companies. So this is the machine learning project if you see over here, and this is deployed, right? This is deployed in Heroku, and this is quite super good because I have used GitHub Actions. See, GitHub Actions, right? And if you see my Heroku, you'll be able to see I have already deployed this. You will be able to see what all steps it had taken, what is the build process. This is all our CI/CD pipeline. What is setup job, right? What all things basically happened. Check out, build, push, and release a Docker container to Heroku, post checkout, and complete job. So all these things I will teach you from basics, from everything. Okay. Um and I just do 2 to 3 assignments of this. Okay, I really want you all to do all these things because in the next one, right, when we are solving this kind of problem statement, what we will do is that we'll try to take up all this particular data set, convert this into vectors, and train into LSTM. After this, LSTM will be hardly 5 lines of code. After we convert this into vectors, it will be 5 lines of code. How long NLP session will take? It will be, I have to complete bidirectional LSTM, transformers, BERT, right? So there are some days, but let's see how much time it will take. Or I'll take a pause. Okay, I'll take a pause of probably 15, 20 days. After I complete LSTM or all, I'll start into Dockers and all. Okay. Which ID is the best? I feel VS Code is the best, guys. Okay, VS Code is the best. And guys, definitely require your support. Go ahead and take memberships. Make sure that you subscribe Krish Naik Hindi channel so that I come up with this kind of free contents and support you a lot till I can, because again, this will be a lot of efforts and all will be there. But I really want to provide you the best thing. Okay. Why pause? Because see, every day we are having this live session, right? People are losing interest. Hardly 100 people are coming to see the videos and all, right? Yes. So, but I'll not, let's see till how much time it will go. I think 4 to 5 sessions we can cover up an LP part. Okay. But anyhow, we'll focus on this. But 2 assignments, please do it. And yes, please support, you know, take up memberships from my YouTube channel. If you can, give super thanks, something like that, so that, I keep on preparing multiple tutorials as we go ahead. Just a request if you can. But yeah, I'll continue with NLP. The next class will happen on Tuesday because I have classes on Saturday, Sunday. So I will be super. Monday, I may take a leave because too much tired. Okay, fine. This is it for my side, guys. Thank you, one and all. And yes, I will continue the LSTM practical part on Tuesday. Okay, thank you. Bye bye. Take care. Hit like. And yes, I will see you all in the next video. Tata. Take care. Bye bye. Thank you for attending. Okay. Yeah, in FHDS class, this all things will be getting covered. Okay. Thank you, guys. Bye bye. Take care.